couple of sections left for chapter 2. They're both talking about proofs. This one is a little bit more talking about proofs than the last one, but this is an introduction to double column proofs. Last section we looked at algebraic proofs, where we had the 2 columns. You did your algebra on the left without showing your work, and then you had your reasons on the right. These are similar, but they're going to be about geometric statements instead of algebra. So this is very introductory, but this is what they will always look like. There's always going to be a given, something that they give you that is true, and then there's always something you're trying to prove. There's going to be the 2 columns, your statements and your reasons. There's always going to be a picture. And we are always going to do double column. The book is going to talk about paragraph proofs and flow proofs. Those are 2 other forms, just a different way to organize the information. We're going to just focus on making all of our proofs double column. Okay? Questions? Okay, so let's try 2 proofs. This is the if-then sentence that we're basing it off of. If a triangle is a right triangle, then the acute angles are complementary. We're trying to prove that that is a true statement. So whenever we're doing proofs in this chapter and also the next chapter, I'm just going to ask you to fill in a few blanks. I'm not going to ask you to create the whole proof on your own. When we get to chapter 4, then you'll be doing it from start to finish all by yourself. But this is just an introduction so that you can kind of get a feel for what they look like. So step 1 right here. Well, actually, let's go through the given and the proof. The given is that we have triangle ABC with a right angle B. Okay, looking at the picture, it's definitely a right angle right there at B, which is also the hypothesis of the sentence, a triangle is a right triangle. Okay, in the given, we have a right triangle. What we're trying to prove is that A and C are complementary. What is complementary?
Equal 90.
Okay, so add to 90, just as a reminder, that's what we're trying to prove. All right, so in the proof, step 1 says that angle B is a right angle. How do we know that?
Said so.
Where did it say so?
Given.
In the given, so that's your reason. Okay, exactly like what we were doing in the last section with the algebraic proofs. So they gave us this information that angle B is a right angle. Now let's look at from 1 to 2. From 1 to 2, 1 says B is a right angle, 2 says B is equal to 90 degrees. Duh, right? Okay, if it's a right angle, it equals 90 degrees. No, duh isn't the reason, but good try. Anytime you have something that seems like it's saying the same thing, what we're really talking about is the definition of that thing. So what is the definition of a right angle? That it equals 90 degrees, right? So that is the reason right here. So anytime we have something obvious like that, it's definition of and then whatever you're talking about. What are we talking about here? Right angles. I'm going to abbreviate quite a bit because there's lots of writing. You are more than welcome to as well. Definition of right angles. Okay, this next one is filled in because I haven't talked about this yet, but hopefully you already knew this. We're going to be using this quite a bit in geometry. The 3 angles of a triangle always equal 180. Okay, that's simply called the triangle angle sum. Okay, not a very common reason, which is the main reason that I put it in there for you. Okay. All right, so let's look at from 3 to 4. What happened from 3 to 4? Well, it's a different way to say plugged in. What's the more math appropriate? What? They substituted angle B and made it 90. Why can we do that?
Because it's a 90-degree angle.
Because they're the same. In step 2 we said that. They were the same thing. So we substituted 90 in for angle B. So that's what happened in that step, was substitution. Now, step 5 right here, from 4 to 5, they kind of did 2 steps in one. Well, no, sorry, I'm talking about 5. I'm thinking about the proof coming up. Erase what I just said. What happened from 4 to 5? They subtracted 90 on both sides. Can you see that? Okay, so that's subtraction. Let's look at from 5 to 6. 5 says A plus C equals 90. 6 says A and C are complementary. What do you think? Duh, right? So what do we write?
Definition.
Definition of
Complementary.
complementary. I'm going to abbreviate definition as DEFN. And I'm going to abbreviate complementary as comp. Okay? So anytime you're really saying the same thing, just in a different way, it's definition of, and it truly is the definition of complementary that the two angles add to 90. That's what complementary means. Questions on those? Let's try one more proof. Okay, in this one, the given is that V and W are congruent and they're supplementary. We're trying to prove that they are right angles. Okay, so let's look at this one. What is the reason for W congruent to V? How do you know that?
Given.
It's given. Where do you think givens are usually going to be in a proof?
Top.
At the very top. It's probably a good guess. And if you don't write down the given on the test, it's pretty sad. Let's just be honest. You can at least write down the givens. Those are the gimme points. Okay. How do we know that W and V are supplementary?
Given.
Also in the given. So notice up here in the given at the top, it says V and W are congruent and supplementary. So they just split them up into two steps. Okay. So both of those things were given to us as true things. All right. Well, let's look at this one. W plus V equals 180. How do we know that?
Because there's definition of supplementary.
Right, from here to here, 2 says they're supplementary. Well, supplementary just means that they add to 180. So this one is definition of supplementary. What happened from 3 to 4? Did something change?
Substitute.
Yeah.
The W or the V turned into a W. What's the reason? I heard someone say it. Substituted. These are the same in number in 1, so we can just substitute that in. Okay. Okay, this is the one that I was thinking in my head on the previous proof. They really did 2 things in this step. What are the 2 things? From 4 to 5, what did they do? First, they combined like terms. So it would really be 2 angle W equals 180. And then they did what to both sides? They divided by 2. Okay, so the step here is really division. They divided both sides by 2. Okay, what changed from 5 to 6?
Substitute. Yeah.
The W switched back to a V. Okay, so they substituted that in. Okay, how do we know number 7? Look previously here. How do we know number 7?
Definition of right angles.
Yeah, if they're equal to 90 degrees, they're right angles, correct? It's another one of those duh statements. So that's a definition of, and we're talking about right angles. So really proofs are just putting your reasoning in a logical order that would make sense to anyone who would read it. Okay, which is really stretching your brain to argue well. We're arguing that if V and W are congruent and they add to 180, that W and V would have to be right angles. Okay, so this was the step-by-step reasoning through that. We're going to review 2 things, but are there questions on this proof? Okay, lastly on the notes, let's just refresh our memory from chapter 1, what segment addition and angle addition looked like. Okay, so let's draw a segment and put 3 points on it and label it A, B, C. Anyone remember what the angle addition postulate said? I'll start it. AB plus equals. Perfect. So if you see this anywhere, which you will either today or on the workbook assignment, or maybe on the test, hint, hint, what would the reason be over here on the right-hand side? Like, let's say this was step 3 in a proof. What would the reason be? Segment addition.
Would just addition be wrong?
Addition would be wrong because addition means you're adding the same number to both sides. Thank you for asking that. So segment addition is a possible reason that you might want to use. Angle addition, let's draw an angle. And put another ray inside of it. And let's put some points on here too. So along the same lines as segment addition, what do you think angle addition would look like? Which angle is XWY? The top one right here, okay? That one, plus YWZ, which is the bottom angle, has to equal the whole angle. Okay, so if you had this on a proof, your reason would be angle addition. Part plus the part equals the whole. We went through that in chapter 1. Okay, you may also see reflexive. We learned this yesterday. Give me an example of what reflexive looks like. So give me something for an example. Nope. Good guess. That's reflexive. What if I had CD right here? Is congruent to. When something is congruent to itself, that's reflexive. What's transitive? What do we think of when we hear transitive? Linking together like a train. Train and transitive. So if 1 is congruent to 2 and 2 is congruent to 3, 1 is congruent to 3. That's transitive. Symmetric, you just switch the order. That would be if angle A is congruent to angle C. What would we say for symmetric? Then. Okay, that's just a review from yesterday. We learned those properties yesterday. So it's an option in your homework. Okay, so you're not going to have to create a proof completely on your own. You're just filling in the missing holes in the proof for right now. Questions?